Hi, and welcome to my talk, Sink Your Teeth into Streaming at Any Scale. Today we're going to talk about how Apache Pulsar and ScyllaDB can help you drive streaming analytics applications. My name is David Karamgard. I'm an Apache Pulsar committer and also the author of Pulsar in Action. I formerly worked at Splunk, where I was a member of the internal messaging team running Pulsar at scale at up to 10 petabytes of data per day. I was formerly director of solution architecture at Streamlio, and I want to introduce my co-presenter, Tim Spann.
Hi, I'm Tim Spann. I'm a developer advocate at Stream Native. I cover what I call the flippin' stack, which is Flink, Pulsar, and NiFi working together. I've been working with different streaming and data systems for a number of years at a bunch of different big data companies. But today we're here to talk about Pulsar and a number of other tools, how they work together to do some pretty amazing things. So we'll look at the agenda real quick, just so we know where we're going and where we are now. We're going to start off with different tools we work together. What is Pulsar? You may not have heard of it. How we join all these different streams of data together with Flink SQL, and how to get data as fast as possible into ScyllaDB. A little reference architecture and some descriptions of how we would do this. And let's start it off. The stream team is pretty awesome. You really need more than one thing to be able to build a real-time application. There's a number of different open source tools that work together really well, and we'll discuss a couple of them here today. But commonly, if I'm building an application, I have Pulsar as my central messaging hub. I'll have Flink in there to do some processing, maybe NiFi to get things going. Of course, ScyllaDB is my sink, maybe some extra analytics with Pinot, some extra ETL with Spark, and maybe some other applications on the side in either Python or Java or Rust, C++, Scala, lots of different language options out there. But like I said, in the center of all this, really important is Apache Pulsar. This lets us, in a cloud native environment, do messaging and event streaming at an incredible scale. And we've been doing this for over 10 years. It started off internally at Yahoo, and today it's become a rapidly growing, well adopted open source project that has some unique features, which is why a lot of people are using it all over the globe. And that just keeps getting bigger and bigger. What's nice with our project, open to as many people want to contribute, and tons of people are noticing it, getting millions of downloads. Lots of people love the project, and you'll see why. One of the critical features that makes it that central messaging hub is you don't have to get stuck with one way of working with your data. We let you get your data into and out of Pulsar via a lot of different protocols, mechanisms, different ways of doing it. So you could use the Pulsar protocol, which makes sense if you're building new apps, but you may have Kafka apps. You may have RabbitMQ apps. You might have MQTT around IoT devices. You could use all those protocols. You get your data into different Pulsar topics, and then how you grab it out for your particular application describes if it's a messaging app or if it's a streaming app, and you could add as many of these as you want, and it makes it pretty powerful. To me, being able to do key shared and just being able to stream very easily based on a key, great for CDC, or in case you want to have one consumer grabbing every message in order, get set up failover, and if they stop working, automatically fails over where you were to a backup consumer, so you never lose data and you never slow down. That's really cool to do. If you want to have someone grabbing all the messages as fast as possible, don't care the order, do it exclusive. That keeps other people from looking at your data. Let them get their own subscription. It's like Netflix. Don't let 12 people use your same account. Shared, I want to do a work queue. Get me every message as possible, fast as possible. Maybe I'll spin up 10,000 consumers, as many as I can do in my environment. What's cool with Pulsar as well, and why we can make it a central hub, is you can have multiple tenants, lots of different companies, users, apps, all on the same cluster. You set up a tenant for each one. Under the tenant, have as many namespaces as you like, so you can really discreetly have your applications together. That's great for security, great for moving around to different environments. It's just a great modular idea. And then on the bottom, let me drop a few 100,000 topics. Get a million topics, no problem. Now, to make sure your data isn't just a bunch of junk floating around, we make sure you've got a schema. We let you have a schema registry without having to run anything else, having to figure it out. I take my app in Python, Java, Go, whatever you have, and I just find the schema in a very simple manner. Couple of fields, a type. I push that in the first time into a topic. Boom, I have a version schema. Whoever consumes it can get that schema, can access it with REST or DevOps. Really easy way to have versioning of your data and have a contract so you know what is this data and what is it doing. Now, if we did just that, I'd be pretty happy. But there's a lot of things in there that make things pretty amazing for scaling, for handling massive load. Automatic load balancing is possible in this system, so you don't overload a broker. This is common in other systems where you're getting into trouble, where one broker gets too much messages, too much traffic coming through. This consensus moves that data around. It's an important feature that Pulsar supports just as the way the architecture is. This could come in really handy so you don't have one broker slowing down your whole system or one crashing because it's getting too much load. Even though there's other brokers sitting out there, maybe new ones you spun up that are just sitting idle. This is very important. In other systems, you might have to do that manually, or it might not even be possible. You might have to move a whole new workload from scratch there or bring down the system. Don't have to do that here. That's just one of those key differentiators that we'll point out here. Things like acknowledgement-based retention of messages. This is more important than that huge phrase sounds. So if I can't acknowledge a particular message because maybe there's something wrong with the downstream system, I could skip and go back. Other systems, you got to go in order or you have to fully stop. Maybe I'll come back later to a message and be able to get it. Having that acknowledgement that, yes, I agree that that's okay. I've processed it. Really important. Tiered storage, so I don't have to worry about keeping every message that I need to have right away in local expensive storage. Send that out to S3, fully available, still can consume it, still use it in queries, but a lot cheaper, and you don't even have to think about it. This is great once you start getting into, petabytes of data. Who can afford to have that in SSDs? Not too easy. Being able to have different types of queuing, so I could do round robin, I could use keys, I can handle dead letters, which is important if a message has nowhere to go. We're not going to lose it. I don't have to implement something on my own, built into the platform. Very easy to elastically scale this up because the brokers that handle messaging and communications are different from storage. So obviously you'll have more consumers and producers of data than your storage of it. And those nodes that are just doing communications, a lot lighter, don't need a giant disk on them. Like I mentioned before, millions of topics, which is really helpful. That multi-tenancy, geo-replication, so when I need to scale that out, whether it's multiple data centers, multiple clouds, different availability zones, very easy. And all encryption everywhere if you need it. Pretty good idea. So we've got a central hub, but how do I join it with other systems? How do I write applications against it? How do I do the fun stuff out there besides just distribute messages? There is a full Flink connector here supported by the Apache Flink community, obviously with help from Pulsar. Lets you easily read and write to data from Pulsar without any extra difficulty. This makes anything you put in a Pulsar topic look like a table to Flink SQL. So it makes it very easy to join these real-time data sources as events come in. Couldn't be easier. Whether you're getting data from Flink into Pulsar to do whatever you're going to do next, or the other way around. And obviously, multiple places where I can connect this to those other parts of our team, things like Scylla, things like Pinot, whatever you have out there, very good to do. Flink itself, really powerful project. You're going to be hearing more about that every time. It's just being adopted everywhere. What's cool about Flink and why it works really well with Pulsar It's having that united computing engine. So I can do things like batch, stream, doesn't matter. However, whatever makes sense for your use case, use the same very scalable system for that. We could have things store state if we need to have it, things like aggregates or computing data over these massive sets of data coming in. Flink SQL is very full featured. You could do things like inserts, you could do joins, you could do updates, upserts, deletes, lots of cool stuff there. Use that for continuous SQL, continuous analytics. So as events come in, I can keep running. I never have to stop. Pretty powerful system out there. Streaming tables make very interesting applications because your data, and again, it has to be pretty structured because you have to set up tables, which is why we have those schemas. It just never ends. As events come in, you just get larger and larger, and you just could process them as they come in or as a unit as they keep growing. What's cool is they don't change, so you get new events, but the old ones are not updated in that way. If you're doing an upsert, it's a different thing on how that works depending on what different Flink connectors you have. What's cool is once you make that connection, that whole namespace will be mapped for you to the catalog. You don't really have to write each table by hand or create your own DDL. You certainly could, but most of the time we'll just use that catalog to do it for us. Now I'm going to transfer this over to David so he could show you some exciting stuff that's been updated and how we get data from Pulsar topics into ScyllaDB tables. Take it away, David.
All right. Yeah, great job, Tim. Thank you so much. So as Tim mentioned, we have a lot of different integrations into Apache Pulsar. Apache Pulsar is a central messaging bus. Think of it as a data repository for your streaming time-based data for all the individual events themselves. And so making use of this information requires a lot of integrating with a lot of systems, as you mentioned before, streaming with the team. And we store a lot of this information, all these different connectors, as it's shown here on the left, in Hub and what we call Connector Hub or hub.streamnative.io. We have all these different processing engines and connectors, as you mentioned. So we highlighted Flink SQL, some of that in Spark also. But what we're going to talk about today is connectors there, sort of in the middle, where we allow data to go into and out of Apache Pulsar very easily with these drop-in connectors. You do a few configuration changes, press a few buttons, and boom, you're either reading data from these sources, bringing it into Pulsar, or you're taking it from Pulsar and writing it directly into these external systems. And specifically, I've been working on the ScyllaDB sync connector, making some additional changes to that so that you can do this processing that Tim talked about, streaming some real-time analytics data. Again, let's say IoT data coming in. You can do your analytics on it. You can do some pre-computing queries, things for like machine learning and feature calculations ahead of time, compute all this information, and then write it directly into Scylla very easily, transparently. If you want to go to the next slide, Tim, you can talk about that. So this is drilling down into that. We have some details there in that link. Please go in and look at some quick starts on how to take data from Pulsar and directly into a ScyllaDB database. Just a few minor configurations. Again, as I mentioned before, your host names, your username, password, the table that you want to write the information into, all that information, you provide the bare minimum, and the data will automatically stream from the whatever topics you specify the data comes from and go directly into your ScyllaDB database tables. Next slide, please. So we have made some additions. We've done some presentations in the past. We found some gaps in this with our ScyllaDB connector. We've always been trying to integrate it as well as Scylla emerges and evolves. We've been trying to keep up with them and adding some new features. So we've added some additional capabilities to the ScyllaDB connector. You can follow it on this pull request release here in the Apache Pulsar project. We've added some interesting capabilities where we can dynamically interrogate the database schema to determine what the type definition is. Before, you had to do a static schema definition, say, I want this table. This table looks like this. All the fields in the Pulsar schema that Tim mentioned earlier would have to map, and you'd have to do this mapping one-to-one. Well, we've made that a little more loose. We made it more intelligent so that as your schemas evolve on either side, let's say you change your data profile in Pulsar, it doesn't break your dumping the data into ScyllaDB, and vice versa. If you add tables or columns to your ScyllaDB, we don't want your connector to break because there's not exact one-to-one mapping. So we've made it more intelligent. We've had support for a lot of those different capabilities in there. I've also added the ability to extract values from what we call generic schema types. So Pulsar it has strongly typed schemas. You can define them in Avro and JSON, these other strongly typed schemas. And we also support what's called a generic record, which has like a map interface or key values interface. And so if you want to dynamically put just a bunch of keys and values, as long as the keys map to field names, this connector is smart enough to say, okay, that goes in this particular table in this field, and this one goes in that field. We do automatic type conversion for you as well. We've also added, if you want to put in raw JSON strings, we'll parse the JSON for you automatically. So again, you don't have to make that. You can break that decoupling of those schemas between the two. And then we've obviously added some performance improvements and some bug fixes. We've added some different schema capabilities and some security capabilities. And on the roadmap, we're going to add some intelligent routing and sharding. I know that Scylla has these capabilities to route the data to the proper nodes. That's on our roadmap to get that done in the next release. So lots of interesting things coming down the pipeline with that. Next slide, please. And so, yeah, we think that by adding these capabilities that ScyllaDB and Stream Native, which is a provider of Apache Pulsar, make a great system for building real-time analytics applications. Has all the different capabilities. You have a very fast distributed database system and a very fast stream storage system and integration to all the different stream processing engines that you need so that you can service different use cases. Again, real-time analytics, real-time machine learning, any sort of high-speed data streaming pipelines you need for log analytics, IoT use cases. Again, calculating feature sets for machine learning models as the data comes in. All these capabilities are now made very easily with these two technologies merged together. Next slide, please. And just last one, talk about reference architecture, about how we envision putting all these pieces together. Again, best practices. Tim started off the talk with these are the different tools that you want to use for your tool set. This is sort of how we map them out together. So again, you can have data coming into ScyllaDB or coming in from Flink processing. So these microservices, these MQTT protocols, these sensor devices will get fed into Pulsar. They're kind of the sources at the bottom. You can then use the Apache Flink SQL tool to do some analytics on that information. Calculate some running averages, for example, over time windows, and then publish that back into Apache Pulsar topic. And then from that particular topic, feed that data into the ScyllaDB directly, again, using that sync connector that we talked about in the previous slides. And so you can have a continuous sort of ETL pipeline doing, extractions, transformations, loading, analytics on that data and making it available. So directly from your IoT sensor devices, a consumable to Scylla tables, almost, as fast as Pulsar and Scylla can do it. You can also do some additional analytics on these visualization tools, things like Apache Pinot or Superset, these other query tools that you can either go directly against Pulsar, or again, you can point at other different data sources as well. So this is sort of the data in, the data out sort of reference architecture that we envision for Pulsar and ScyllaDB working together. Next slide, please. Last but not least, again, we mentioned, talked about this in the previous slide, the right tool for the right job. You bring a lot of tools to a real-time pipeline developing exercise. And so again, the Flink SQL that we mentioned here is for continuous analytics, doing it for ingest, doing real-time joins, joining different data sets together. Let's say, you have IoT sensor data. You maybe want to join that to some static data to say this is in, my plant A, or this is plant B, this is this sensor type or that sensor type. Enriching this data, continuously enriching that. You can use things like Flink for that. Once you have that information in there, you publish it to Apache Pulsar. You can do some additional routing or transformation on that, store the data there, so backing up. And then eventually, again, once you attach a sync, you can route those pre-calculated values into ScyllaDB so you can have instant real-time lookups. So these applications can, again, do like feature calculations for machine learning model. I go look at what's the key for this particular sensor type. I can get the last reading for the last hour, 2 hours, 3 hours, all these different averages, and store massive amounts of data very quickly and access it in your real time. And then there's also Apache Pinot for low latency instant query results if you want to use that as well to attach it to these other systems as well. And thank you so much for attending our talk. Please stay in touch. This is both my contact information here as well as Tim's. Scan the query code for more information, free downloads. Reach out to us on Twitter, email, our GitHub accounts, LinkedIn, all different ways to get a hold of us. So hopefully you found this educational, and I'll let Tim give any parting thoughts as well.
Yeah, definitely stay in touch. There's a lot of different things you could do with these technologies. So reach out if you have some innovative things that you want to have questions on or help us solve some hard application problems.